So let me start again. So multiply both sides by 1/2, right? Instead of 1/2, I can rewrite 1/2 as 2 to the -1, which is inverse of 2. I can do that, right? It's the same thing, right? 1/2 is the same thing as 2 to the -1, right? And then 2 to the -1 times 2. This is 2 to the 0. If you multiply two same bases, you add the exponent. So -1. I'm sorry, 2 to the first. I'm so sorry, 2 to the first. So -1 plus 1 is 0, right? 2 to the 0 is still 1. But the point is, 2 to the -1 times 2 is cancel. It's just 1, right? That's just 1. Which is leave you just x equal 2 to the -1 times 3. And then it's equal to 3/2, right? But which I'm not going to write it here because it's not my point. But my point is that I'm going to use this form. I'm going to use that form. The inverse multiplicative inverse. In general, we use the multiplicative inverse of a real number to solve a algebraic equation of the form ax equal b. So basically, I multiply both sides by a to the -1, a to the -1. And apparently the left-hand side cancel, right? So leave me just x equal a to the -1 times b. That's my point, right? Same thing with matrix. Same thing with matrix. We're going to use the inverse matrix. Here, capital A inverse is the whole matrix. It's no longer a number. It's the whole matrix. We're going to use that to solve ax equal b. So what we're going to do is we're going to multiply both sides by A inverse. So that A inverse times A is just the identity matrix. In matrix, the identity matrix is same thing as like number 1 in algebra, right? So just leave me just the x, just the matrix, the variable matrix x equal A inverse times B. And you know how to multiply two matrices, right? You can use calculator for that. All right, so before that, before we do all that, let me introduce you the A inverse matrix. Let A be a square matrix of a size n by n. A square matrix A inverse, denote A to the -1, is still the same size, which is n by n, such that if you multiply A times A inverse, it's the same thing as A inverse times A equal I. Now, let me give you a little note. In general, matrix multiplication is not commutative. That means A times B is not always equal B times A. It's very rare. It's very rare that they equal. Even though if they the same matrix, even though say, yeah, it's very rare that they equal, right? Usually they don't. Now, in this case, I claim that this look like is commutative, right? A times A inverse equal A inverse times A is commutative, right? Why is that? Well, why is that in this case it's true, it's okay? Why is that in this case true?
Because it's A times A, not A times B.
Very good, because it's the same thing everywhere. The entry is the same, right? First of all, it's the same size. It's say, if I say usually 3 by 3 is the most popular size, say 3 by 3, A inverse is still 3 by 3, and that means you be able to multiply back and forth both ways, right? The second point is that because all the entries inside A are the same, right? A inverse, A and A inverse are not the same per se, but A here and A here is not changed, right? This here and this here is not changed. And because I don't know that if you remember from 662, is it 662 or recently? I don't remember. But if a function say f of x, don't write this down. I have nothing to do with this. And if I can find the inverse of f of x, which is denote f inverse of x, then if you combine them, remember composite function, f inverse of x is equal to x, equal to x. And same thing, if you put the inverse outside and then put the function inside, f inverse of f of x is also equal to x, right? So it's kind of similar to this, similar idea, right? Not computational wise, but similar idea. Just remember, A times A inverse is equal to A inverse times A equal I, okay? Equal the identity matrix. All right, let's check. I want to check if I want to show that this matrix right here is the inverse of this matrix. One way to check is to use the definition, right? If you multiply them and they turn out to be the identity matrix, then yes, they are inverse of one another. Right, so let's check by multiply them. So negative 1/5 times negative 1/5, 1/5, 2/5, 1/10, multiply, put it down here a little bit, multiply negative 1, 2, 4, 2. I don't feel like doing this by hand, so I'm going to use Desmos matrix. You just have to, I'll take a picture. You don't have to tell me where it is. Matrix A is a 2 by 2. Oops. Negative 1/5. And then 1/5. And then 2/5. Oh, this thing's wonderful. 1/10. And matrix B is also 2 by 2. Negative 1, 2, 4, 2. And then A times B right there, down there, you see A times B, I already have it there. So it's an identity matrix, so yes, right, it's true, right? So yes. One, 0, 0, 1. So yes. So far, so good. All right. This question for you. Why the only square matrix is invertible? Why not a rectangular matrix? Anyone? Anyone? Why is it only square matrix invertible? You don't have to give me like a very deep like a deep explanation, because that's, you know, for proving people for what they call that class 300 math. Alex, you like Lexi, you remember? It was a math 300 something. Is it mathematical proving or something?
For proving this.
Yeah, it's 300 level. I forgot. It's
I
301
think
or
I
something.
did it. I want to say we talked about it in linear algebra for the 2775.
Okay, yeah, maybe that in linear algebra they do that same thing too, but we're not there. We don't have to prove it abstractly. Just give you just an idea, like why only square matrix is invertible. First of all, if you look at the definition of a inverse matrix, what is the size? The size have to match with the original matrix, right? So if you start out with n by n, you're gonna end up with n by n, right? So if you start with n by n, and if you end up something n by m is not right? Then it can't be inverse, right? By the way, you cannot operate an inverse on a non-square matrix, right? It's just impossible, just because of the formula, how you do it, right? Just impossible. So that's the idea why. Now, furthermore, not every square matrix has an inverse. It's kind of like function, not all function has an inverse, right? So for example, y equal x squared is a function, but if you don't restrict the domain, then it's not a inverse, it does not have inverse function, right? So not all square matrix has an inverse. Same idea. All right, let's find the inverse of this matrix. This is 2 by 2. Now, later in this slide, I'm going to tell you the formula to find the 2 by 2 inverse matrix. But let's say I haven't given you that formula yet. We're going to use brute force. Right? Use what you know. Brute force means you what you know, right? No formula necessary. So I want to find inverse of this. I know that if I know that A times A inverse is equal to the identity matrix, right? From above, right there. So if this is matrix A, then I'm going to take the matrix A, which is -1, 3, -2/3, 2, and multiply with the A inverse, which I don't know the entry. I'm going to call this ABCD. And you multiply them together, they better be the identity matrix. We did this before, do you guys remember? We kind of did this before, the last lecture, sort of. Now, how do I solve for A, B, C, D? Matrix multiplication, right? So we're going to take the first row times the first column. -1 times A plus 3 times C. So -A plus 3C. And then the first row times the second column, entries to entry, -1 times B. So -B plus 3 times D. So plus 3D. And then move on to the second row of the first matrix. Second row times first column, -2/3 A plus 2C, and then second column, -2/3 B plus 2D, equal the identity matrix. Yeah. Matrix, equality of matrix. If the left matrix equals to the right matrix, then each entries have to be equal, right? So I can set up a bunch of equation from this. I have I have -A plus 3C equal 1, and I have -B plus 3D equal 0. I have -2/3 A plus 2C equals 0, and -2/3 D plus 2D equal 1. I'm going to call them equation 1, equation 2, equation 3, and equation 4. Can someone tell me what equation I should combine?
One and three and two and four.
Very good, right? 1 and 3, 2, 4. So let's do one pair at a time. So I need to combine 1 and 3. I'm going to eliminate, say I'm going to go to eliminate the A. So I'm going to multiply the first equation by, say, negative 2/3. Sounds good? Yeah. So negative 2/3, let me use blue, negative 2/3 times equation 1, add to equation 3. So I have positive 2/3 here, A. Negative 2/3 times 3 is negative 2. So minus 2c equal negative 2/3. And then rewrite equation 3, which is positive 2/3 A plus 2c equals 0. And then you add them together. What happened? It looks like everybody on the right-hand side cancel. So it's just 0 on the right-hand side. And on the left-hand side is equal to negative 2/3, which is false. If you cannot solve, then it's no solution. If it's no solution, then you won't be able to figure it out what A, what B, what C, what D, right? So that means no A inverse, right? So no A inverse, all that work, no A inverse. So your final answer A has no inverse because you can't solve. If you be able to solve, then it has an inverse, but you can't solve. All right. We'll come back to this just a little bit. We'll come back to this. Just there's one more point I like to point out. But let's move on to the next page, which is finding the inverse of a 2x2 matrix. I promise you, you have something like this on the exam. And you want something like this on the exam as opposed to 3x3. It's easier. So given matrix A, which is the square matrix, ABCD, ABCD for the entries. If I want to find the A inverse, it's going to be equal to 1 over, or A times D, I'm sorry, typo, A times D minus B times C. A times D minus B times C. And then times the sort of new matrix, well, it's kind of new. So they switch for the A and D, they switch the order. So A becomes D, D becomes A, right? For B and C, stay the same where they are. However, the sign changed, just opposite compared to the original, all right? Where AD minus BC is your determinant. We'll talk about the determinant later. Now, the determinant for a 2x2 matrix. Let's do this first, and I'll talk about that later. Let's do about this first. So I want to find the inverse of A using that formula. And on the exam, this is the formula I want you to use if I ask for a 2x2 inverse matrix, okay? You don't have to use this brute force approach unless you want to, but use a formula. It just make your life easier. All right, to plug it in, 1 over A times D. So here's my A, here's my B, here's my C, here's my C, here's my D. So 1 times 0 minus B, which is minus -3 times 5 times the new matrix DA, so 0, 1, and then negative B, so opposite of -3 is +3, opposite of 5 is -5. 1 over 15 right? 0 minus 15 is 0 plus 15. Time that matrix 0, 3, negative 5, 1. And then you know how to do scalar multiplication, right? All you do is just take 115, multiply every single entry inside the matrix. So 115 times 0 is still 0. 115 times 3 is 1/5. 115 times negative 5 is negative 1/3. And 1/15. That is your A inverse. So far, so good. Do you have any question? All right, so that's how to find the inverse of a 2 by 2. There's a formula. You're supposed to remember it. If you forgot, I'll remind you, but on the final, I cannot remind you, okay? On the exam, I can remind you if you ask me, but on the final, I don't think I can. I'm not the one who only make the decision. All right, now let's talk about the determinant. If you look at the determinant, by the way, the notation for the determinant is capital D, right? They call capital D stand for determinant. If the determinant is 0, then that matrix does not have an inverse. Say, don't write this down. Say hypothetically, if under the denominator here is 0, the whole thing is 0, 1 divided by 0 is undefined. So you stopped, right? If the determinant is 0, you stop. That matrix does not have inverse. Let's go back to this problem. Let's check the determinant for this matrix. I just want to check the determinant. So let's check for the D. So 1 over, just D. I don't need to do 1 over, just D. So AD minus BC. A is negative 1/2 times D is 2 minus B is 3 times negative 2/3, which is negative 1 plus 1, which is 0, right? That's why we don't have a inverse for this problem. So for me, it makes sense if I ask you to find the inverse of some matrix. It makes sense for me, it makes sense for you to check whether the determinant is 0 or not before you do the procedure. It saves you time, right? If it's 0, then you don't have to do anything, right? All right, 3 by 3. Let me see, how long do I have? All right, I have time. All right. Let me show you the procedure, the algorithm, how to find the inverse for a 3 by 3 matrix. We don't have a formula, I'm sorry. But I'm not going to explain it to you why we're doing what we're doing. You can read it from the book, because on the exam or final, I'm not going to ask you, or they're not going to ask you about how, or they're not going to ask you about the why, but they're going to ask you about the how, right? So let's practice the how first. So first, you're going to write, given a matrix A, you're going to write it at A and then the vertical line, and then the right side, the vertical line, that will be a identity matrix. Okay, so for example, this one, I'm going to write like this. So the left-hand side will be matrix A. So we write 2, 1, 1, 3, 2, 1, 2, 1, 2. And then the vertical line. On the right-hand side will be your identity matrix. This is 3 by 3. So 1, yeah, I would use black. 1, 0, 0, 0, 1, 0, 0, 1, 1. So this is matrix A. Let me do like that. That's matrix A. And this right here, that's the identity matrix. Right. Now, Don't write this down yet, but at the end, this is my goal. At the end, I want something like this. Ultimately, we want something like this. It's still the big long matrix, and then we have a left matrix and then the right matrix. Now now at the end, the identity is going to be moved to the left. So here is going to be the identity matrix, and on the right is going to be your A inverse. That's our goal, right? We're gonna use Gauss-Jordan elimination. That's step number 2, to rearrange it in such the way that on the left side is going to be identity, and the right side is going to be a new matrix, and that will be your inverse matrix. Okay. All right. Let's do this bad boy because it's kind of long. And I promise you on the exam, it'll be very, very reasonable. All right, let's do this. Oh, I want my first entry to be a 1. But let's not worry about that yet. We do like this. Okay, so here is the deal. You remember the Gauss-Jordan elimination, right? So first you identify your diagonal, right? Anything below the diagonal has to be 0. So this guy has to be 0. This some number here has to be 0. Some number here has to be 0. It's gonna change when you do operation, but that's the general idea, right? Anything below the diagonal has to be 0. Now, not only the below the diagonal is 0. Now everything above the diagonal also has to be 0. Your quiz last time, you did your quiz number 4. I only make you to do the below the diagonal 0, right? But I never really asked you to do the above 0. That's the calculator. But today we're gonna do both. Today we're gonna do both. All right, so let's do the below one first. That's easy. Everybody knows how to do that. At least most of us. Okay. I need to make let me erase that. I need to make the 3 zeros. So what should I multiply the first row by? Anyone?
Is it -3/2?
Yeah, -3/2. So -3/2 R1 add to R2, give me new R2, right? Very, 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 very similar to what you did. So the first row is the same. We rewrite it so we don't forget. 2, 1, 1, and then the vertical line, and then 1, 0, 0, close the parenthesis. Now the second row is going to change the whole row, both left and side. So the first entry is 0, is what we want. Use calculator. Don't do this by. Don't do. Use calculator. Make your life easier. -3/2. All right. So what I'm going to do is, I'm going to store -3/2 at x, so I don't have to keep typing -3/2 all the time. So -1.5 STO to x. All right, first one 0. Now the second one. So -3/2 times 1 is still -3/2. Actually, maybe I don't need to. Add to 2. -1/2, right? So -1/2 plus 2 is negative. I'm sorry, yeah, -1/2, 1.5 plus 2 is -0.5, so -1/2. -3/2 times 1 is 1 plus 1. Oh, sorry, the first one is +1/2, my bad. And the second one is -1/2. Yes. Yes, all right, we are okay. Keep going. -3 times 1, I'm right here. I'm right here. -3 times 1 is still -3/2. Add to 0 is still -3/2. Next one. -3/2 times 0 is 0. Plus 1 is 1. Oops. And then the last one, -3/2 times 0 is still 0. Add 0 is 0. So far, so good. It's a little bit longer than it used to be. All right. I need to eliminate this one right here. That 2. So I'm going to multiply the first row by what now?
-1.
Yeah, -1, right? So let's do that and add to row 3. So let me write here, -1 R1, add to R3, give me news R3. -2 plus 2 is 0. -1 plus 1 is 0. -1 plus 2 is 1. -1, I'm right here. I'm going to the right-hand side now. -1 plus 0 is -1. -1 times 0, 0, plus 1 is 1. Did I? This should be 0, right? This should be 0, right? Yeah, my bad. That's typo. So 0, 0 here. Oh, no. Typo. 0 here and then 1 here. Typo. So let's see. Let me erase the last two entry. Let me erase the last two entry. -1 times 0 is 0. I'm right here. -1 times 0 is 0. Plus 0 is 0. And then -1 times 0 is 0 plus 1 is 1. Whew. I don't want to get wrong, and then the whole thing is just garbage. All right. We lucky. Look at that. One stone, two birds. We also eliminate this one by accident, that one right there, which is good, right? So we don't have to do another step. We don't have to use the second equation. Now move on to the upper triangle, the one above the diagonal. The order will be this. You eliminate this first, and then this one, and then this one. Just how like you draw a right triangle. Right? You go like that. Right, so let's do that. Let's eliminate -1/2. Let me ask you, which equation should I use to eliminate the -1/2? What equation should I use? You know what? Let me do this. I don't like the fraction, so can I multiply the second row by 2? Is that okay? Just try to avoid fraction, that's all. So 2R2, give me new R2. Everything else stay the same. Just try to get rid of the fraction. 2, 1, 1, vertical line, 1, 0, 0, and then 0 here. 2 times 1/2 is 1, -1, -3, 2, 0. Rewrite the last one as well. All right. All right, so let me redraw my diagonal here. That's my diagonal. Let me delete that diagonal there. Now I need to eliminate the -1 here. Which row should I use? Anyone?
The third row.
Yeah, why? Very good. Third row. Well, why do we use third row?
There's zeros.
Because we don't want to change.
Yeah, the zeros are.
Yeah, we don't want to change the second row, right? We don't want to change that one there. We don't want to change that one there. So use the third row. So all you have to do is what? Add 3 to 2, right? It's already opposite. All you do is R3 plus R1. I'm sorry, R3 plus R2. Give me new R2. What row gonna stay the same? All three stay the same, right? It's good. It's good because the identity matrix is the last row is 0, 0, 1. So rewrite the last row so we don't forget 0, 0, 1, vertical line, -1, 0, 1. And then let's do the second row. So R3 plus R2. That's it. 0 plus 0, 0. 0 plus 1, still 1. 1 plus negative 1 is 0. Negative 1 plus negative 3 is negative 4. 0 plus 2 is 2. 1 plus 0 is 1. So far, so good. If you have question, please ask. It's frustrating if you don't understand. I understand that. Same thing, if professor says something I don't understand, it's really frustrating me. So we good? Yeah. All right. My next step is to eliminate this one right here.
Do you multiply by -1 to the third row?
Very good, right? Still use the third row, it's fine. We can use the third row, right? Nothing wrong with that. Negative R1 add to negative R3. Negative R3 add to R1, give me new R1. So 0 plus 2 is still 0. I'm sorry, 2. 0 plus 1 is still 1. Negative 1 plus 1 is 0. Negative 1 times negative 1 is positive 1 plus 1 is 2. Negative 1 times 0 is 0, so 0 here. And then negative 1 plus 0 is negative 1. Almost done. Almost done. I need to make this 0. What row do I use? Well, either 2 or 3, right? Can I use 3? No, right? I cannot use 3 because the 0 here, nothing I can do with the 0, right? Add 1 is still 1. So your only choice is row 2, right? So multiply row 2 by, it's lagging. It's lagging. It's lagging. I
-1.
froze. Can you hear me?
Yes.
Okay. Oh, okay. Back up now. Back up now. It was lagging. So multiply the second row by -1, right? So -1 R2 plus 2 R1. Give me new R1 again. I'm gonna go down here because I don't have enough space. So the last 2 rows stay the same. So rewrite them so you don't forget.
Oh, we can't see the screen or
Oh, so it's lagging again. Knew it. Let's see. It's connecting. Come on. Come on. Screen. Oh, we're almost done. We're almost done. Oh, I write too large now. I don't have enough space. Here, give me a second, okay? Let me erase that. I write too large because I need space. So negative R2 add to R1, give me use R1 like that. It's fine. Okay, all right. So the last 2 rows same. So 0, 0, 1, vertical line, -1, 0, 1. Second row stay the same as well. -4, 2, 1. All right, the last row. -1 R2. So let me do like this. So maybe you can see better. -1 times 0 is still 0. Plus 2 is still 2. -1 times -1. I'm sorry, -1 times 1 is -1 plus 1 is 0. So what we want. -1 times 0, 0. So 0 here still. +4 plus 2 is 6. -2 plus 0 is -2, and then -1 plus -1 is -2. Almost done. The last step we have to do is what? Remember, yeah.
Back substitute.
Huh? Oh, no back substitute. We just find the inverse. We're not solving for anything. We're just finding the inverse. Remember the step. Remember the procedure. The left-hand side had to be what? At the end, the left-hand side had to be a identity matrix, right?
So we have to
We
turn
close.
it into 1.
We only have to take care of this guy. So what do I have to do? Multiply the first row by 1/2, right? 1/2. 1/2. So 1/2 R1, give me new R1 again. Because we need to make that into the identity matrix, right? All 1 in the diagonal. So 1 here, and 1/2 times 0 is still 0, so we save. So 0 here, 0 here. On the right side of the diagonal of the vertical, 1/2 times 6 is 3. -1, -1. And then the last 2 rows stay the same. Yay, we done all that work. Yay. That right there, that is your A inverse. There's your A inverse.
I have a question.
Mm-hmm.
So when we first started the problem on the other, like the right-hand side of the box, the identity matrix was like the ones in the horizontal, but it also had a 1. Oh, wait, never mind. No, it didn't. I just copied it wrong.
No, I had it wrong before. No, you're right. I had it wrong before.
Okay.
I fixed it.
Okay, cool.
It
I
was
must have
my
not
fault.
seen that.
It was
must
my
have not
fault,
seen
yeah.
that. Thank you.
Yeah. So that's the procedure, right? The only thing you have to be careful is during the process, very easy to make mistake. And I'll tell you what. Oh, let's check first, and I'll tell you what I'm gonna do on the exam. Now let me check with the test thing. So let me see what my A inverse. A inverse is. Come on, it's lagging again. 3, -1, no, -1, -4, 2, 1, -1, 0. Okay, all right, that's A inverse. Now on your calculator, once you put, everybody know how to put in the matrix, right? You quit, you second mode to quit, and then you go back in, choose the name, and then underneath, I don't want to go to that. I'm scared. I'm gonna calculator. All right. Oh, good God. Quit. Second matrix. I'm gonna go to second matrix. Say name. I'm just gonna pick a matrix. Okay, it's pretend it's 3 by 3, right? And then I want A inverse, so second, and then x to the -1. So second, that x to the -1 below math, it gives you the A inverse. God. Oh, you don't have to do second, just the x to the A inverse right there. So it gives you the. That's how you do on your calculator. But let me show you on the decimals. Next time in class, I will be able to show you with the calculator. Delete is the 3 by 3. Can someone read me the original matrix? Hang on.
It was 2, 1.
Hang on. I think it's lagging again. Sharing. Come on. I hate when it's delete. All right, read it for me, please. Thank you.
It was 2, 1, 1.
2, 1, 1,
3, 2, 1,
3, 2, 1,
and 2, 1, 2.
2, 1, 2. Thank you very much. And then go down here. Delete that A inverse. So press A and then the below F, you say A to the -1. You're gonna press letter A first, right? Capital letter A first, and then that right there. That's all we inverse. Yay, we got it right. All right, so now let me tell you what I'm expecting on the exam. On the exam, you don't have to do this. So that's a relief. On the exam, you have something like 2 by 2 matrix. All right, but I'm not going to ask you to do this by hand on the exam. That's crazy. It's only 1 hour. Now I cannot talk, I cannot promise on the final, right? Somebody else writing it, it's up to him. Maybe you can convince him not to do it. But please know how to do this, all right? Just for the sake of the final. Okay. So sounds good. All right. Sounds